Good afternoon, participants. I am Coordinator Dayachandran speaking. We welcome all of our participants for this International Webinar Series 2. And within few minutes, we will be starting the session. And our guest speaker will be coming within few minutes. Let us have some patience. Once again, I thank all of our participants who are encouraging us to do this webinar series. Thank you.
Good afternoon, everyone. This is Peter Demian from Loughborough University in the UK.
Good afternoon, Professor. I am Dayachandran speaking.
Hello. Shall I go ahead and share my presentation?
Let me give an intro about yours.
Oh, please. Thank you.
Good afternoon to all our participants. On behalf of our Civil Engineering, Department of Civil Engineering from EASWARI Engineering College, we are conducting this second international webinar series for the knowledge sharing purpose for the students as well as for the faculty. When a faculty is getting a knowledge, it will be disseminated to hundreds of students. And a student get a knowledge and he will be disseminating the knowledge to many of the public, that is people. So this webinar series will be a very nice session mentioning about the knowledge sharing from various countries. So now today our professor Dr. Peter Demian have come from England, and he is a reader in building information management under School of Architecture, Building and Civil Engineering from Loughborough University, England. And today our guest speaker will be speaking about digital transformation of civil engineering and construction. And he had nearly 15 years of experience in the academic wise, and he have worked a lot of consultancy works, a lot of research works, and he had got a lot of awards from various categories. And he's a member in many professional bodies like Chartered Institute of Building and American Society of Civil Engineers and HEA. And I welcome our guest speaker, Dr. Peter Demian, to take over this session. Thank you, sir.
Thank you very much, Professor Dayachandran, for this very kind introduction. Thank you very much. Now I will just see if I can share my presentation here so I can start to present. Now the link escapes me. Let's see. Present now, and then I'll put here a window, and I will choose this one. Right. Can my colleagues see my PowerPoint slides now?
Yes, sir. It is visible.
Okay, good. So, well, thank you very much, Professor Dayachandran, for this kind introduction. As my colleague said, I thought I would spend maybe 30 or 45 minutes this afternoon speaking about the digital transformation of civil engineering and construction. This is a very exciting time for us in the UK to be working in these professions in the domain of the built environment. And I thought I would spend a little bit of time to share some of that excitement with you and to tell you some of the research which is both driving this transformation but is also reacting to this transformation. Like my colleague said, I am Peter Demian at Loughborough University in England. Loughborough is a small market town in the middle of England, kind of halfway between the south coast and between the top border with Scotland. So we're right in the geometric center of England. At Loughborough, I am currently the leader of the construction management group, and I'm also the program director for some of our MSc programs, especially the MSc programs in construction management, construction project management, and construction project management with BIM. I do a lot of research on information management. However, my background is in structural engineering. It's in civil engineering. In fact, my master's dissertation was on pre-stressed concrete. And I was hoping as an undergraduate that I would one day become a world expert on pre-stressed concrete. That never happened, but I am sharing this with you because I know that I'm talking today, and it's my honor and my privilege to be talking to such a distinguished audience of engineers, and my background is in engineering. Excuse me. The final thing I'd like to say is I am from, of course, Loughborough University, but from the School of Architecture, Building and Civil Engineering at Loughborough University. And we are a large, integrated, multidisciplinary school, and we do research and teaching in pretty much everything to do with the built environment. And if I can be so cheeky, I'll say a little bit about this at the end of the presentation. So an outline for this afternoon, what I'll be talking about. I'll start with drivers for this digital transformation. Why is our sector, our domain being digitally transformed? Then I'll talk about this idea of digital twins, and maybe even on a national scale, a national digital twin for the whole of the United Kingdom. And then I will wrap up the presentation with some recent research. I'll talk about some of my own recent research in a BIM search engine. I'll talk about national capabilities needed in information management. And then I'll wrap up with some research that we did recently on augmented reality and virtual reality. And then I will wrap up this presentation with some conclusions, especially from a UK perspective. So I'd like to kick off my presentation with this image. Normally, when I present this in the classroom to some of my students, I ask my students, does anybody recognize this image? Does anybody know what this picture is of? And many of them too do know, because this was a huge incident, at least in the UK. Now, I don't know if our international audience and if my colleagues and students from India will know. This was an incident that shook the UK almost 3 years to the day. This happened in June 2017. And there was a terrible fire in a tower in West London called Grenfell Tower. And this fire tragically killed over 70 people, so 70 lives were lost, and many more were injured. And this incident sent shockwaves through the country, that such a thing should happen in a country such as the UK, where we believe that we do really excellent work on health and safety, and we value human life so much, and we take such care of our constructed facilities and our buildings. So it was quite a shock. But this taught us that we need to manage our information more carefully. And here are some of the contextual things that are happening around this. Some of the contextual drivers for the digital transformation. The first thing I put on there is that this is what clients want. Clients want our buildings. Clients that buy buildings, people that hire us as structural designers, as architectural designers, as contractors and builders, these clients that buy buildings want our buildings to be delivered digitally. This is especially true of the UK government, so public sector construction in the UK. And you can see this very much in many of the UK government policy documents, that the UK government wants to be much better at buying information rather than buying a building. They want to buy information about the building as well as to buy a building. And you can see this kind of sentiment in, for example, a strategy document called the Industrial Strategy, Government and Industry in Partnership, Building Information Modeling, or another famous UK construction document called Construction 2025. So if you click on this link, you will see this, or if you Google some of these policy reports, you will see that these are very important policy documents from the UK government that says, or that very clearly indicate, or at least imply that we need to deliver buildings digitally, and the UK wants information about its buildings as it is buying buildings. The second point on this slide is that a digital transformation would help us with more effective delivery of design and construction services. So it would help us to design buildings in a better way, more effectively. It would help us to construct buildings more effectively. For example, it would boost productivity. And one of the things which is plaguing the industry, and if you see many of the government policies, they talk about the staggering waste in the UK construction. How much rework, how much wasted time, wasted effort, how much waste of, for example, cranes left unused on site, which lead to delays and cost overruns. So all of this idea of waste and very poor productivity has been highlighted as a major concern for the industry, both for the government and government regulation of the industry, but also for the private sector, for industry-led initiatives. And you can see this in initiatives such as Project 13 of the ICE, the Institution of Civil Engineers. And I'll talk a little bit more about this very briefly. Other drivers. I put here better operation and maintenance of buildings. So if we manage our information and if we deliver buildings in a digital way, we can operate and maintain them more effectively. And I started off this presentation with the Grenfell fire disaster. As part of the inquiry that followed this tragic accident, the government commissioned a report by Dame Hackett, so it's known as the Hackett Report. And this Hackett Report said that in our buildings, we need a golden thread of good quality information that will enable future building owners to better manage their buildings. In other words, when we as building designers and building constructors, building builders, when we deliver a building, we generate a lot of information, and this information should be maintained during the operation and maintenance of the buildings. And Dame Judith Hackett, who wrote this report, referred to this as a golden thread of information. So we need to maintain this golden thread of information which runs throughout the life of a constructed facility, certainly from design and construction and all the way through to operation and maintenance, which will help us to operate and maintain our buildings more effectively. Improved services, that's the next point I put on there, that a digital transformation will not only help us to deliver better constructed facilities and not only help us to operate and maintain those constructed facilities more effectively, but it will also help us to deliver services that depend on the built environment more effectively. And I'm thinking of services such as transport, public transport, logistics, rail, roads, airports. These kinds of services all depend on the built environment. Even healthcare and education, all of these are essential public services that depend on the built environment. And it is now recognized that if our built environment is digitally transformed, then this will help us to deliver those services more effectively as well. And there is a famous report by the National Infrastructure Commission called Data for the Public Good. And I put a link to that report here. So if you look at this report, it says that how the built environment, things as simple as roads and railways and even healthcare buildings and education buildings, all of this built environment, if it's collecting data and if we can monitor the health of this built environment, then we can provide services more effectively that depend on this built environment. Some final ideas. A very interesting report came out this very recently, just last month, I believe, called "Flourishing Systems," which talks about our built environment as a flourishing system, or society as a flourishing system, and how the built environment can help the system to flourish. And it looks at the people, the connections, the sustainability, and the digitalization. So as an exemplar of all of this, I would like to go back to this initiative called Project 13 by the Institution of Civil Engineers, the ICE. And I'd like to play this video for you about Project 13. And it kind of touches upon all of those drivers for the digital transformation of the built environment. And it talks about how all of this is very important for delivering our buildings and our infrastructure more effectively, but also operating and maintaining them more effectively, and therefore having these essential services delivered to society more effectively as well. So with that, I'll play this video about Project 13 from the ICE, the Institution of Civil Engineers in the UK.
The government's industrial strategy seeks to address long-term challenges to the UK's economy. High-performing infrastructure must be at its core. Without it, we have little hope of increasing productivity and generating growth. And we will not be able to secure the quality of life required by our growing population. Yet the model we use to deliver and operate much of our infrastructure is broken. Too often, projects are delivered over budget, past deadline, and below par. The supply chain seems locked in a cycle of low margins, low investment, and dysfunctional relationships. But if we stop seeing relationships as purely transactional, stop making decisions driven entirely by cost, we can create value-orientated, enterprising teams that come together to deliver programs focused on the demands of their clients and the public. And we are already building a community of infrastructure owners and suppliers committed to making this change. Working with the largest players in the sector, we've identified 5 features that are crucial to this new approach to successful project delivery. Governance. Infrastructure owners must establish rules, processes, and practices to guide their interactions with suppliers and their decision-making. Organization. Owners must engage the right suppliers at the right time and integrate them into the team. Integration. Owners must develop the culture, practices, and systems appropriate to the program being delivered. Capable owner. Owners must have the capability to define outcomes, articulate technical requirements, manage stakeholders, put infrastructure into operation, and work collaboratively with the whole team. Digital transformation. Organizations need to do more than just embrace new technologies. They must devise new business models that change the way they operate. Project 13 is a bold new approach to delivering high-performing infrastructure. Help lead the transformation of our sector and build a better future for Britain. Join our community at www.t13.org.uk.
So that was an introduction to Project 13 from the Institution of Civil Engineers, and even though it's badged or operated, delivered by the Institution of Civil Engineers, this is very largely an industry-led initiative. So this is the industry saying, we need to do all of these things to work better. And I think this is a very good exemplar of all of those drivers that I mentioned in the previous couple of slides. Digital transformation is just one element of this. I think if I was to put a key word to all of this initiative of Project 13, it's about relationships, between the supply chain, between owners and the delivery team of buildings. There is a very crucial and a very topical issue which I need to visit. Now, I've already talked about how one of the drivers for the digital transformation is the ability to operate and maintain buildings more effectively. And I talked about this golden thread of information, which is outlined by the Hackett Report following the Grenfell Tower disaster. Well, one idea which the construction industry is embracing is that of digital twins. Digital twins. And the idea is that if you have a building that is a physical twin, and alongside a physical twin, you need to have a digital twin. And this digital twin can help to operate and maintain the physical twin more effectively. The second point I put on the slide is the digital twin is essentially a model. So this is not a very new idea. We've been talking about computer-aided design, about CAD for decades now. So we know about CAD models. We've been talking about building information models also for a couple of decades now. So we know about BIM or BIMs or BIM models. Nowadays, we talk about digital twins, which is essentially a model. But the difference here is the third point I put on the slide, which is that the model is very tightly coupled with the physical reality. In other words, the digital and the physical twins are tightly coupled. In other words, there are all kinds of sensors and measurements being taken from the physical building, which are updating the digital model or the digital twin. And at the same time, there are all kinds of simulations and decision making, which is facilitated by the digital twin, which leads to action in the physical twin. So there's this very tight coupling. There's this two-way flow of information and of activity and the action and decision making between the physical twin and the digital twin. So this is a very important concept which we are embracing in construction, especially here in the UK, this idea of digital twins, even though, as I said, it's not a new idea. Now, the second half of this slide talks about a national digital twin. So a digital twin on a national scale. Now, this might not necessarily be one huge Revit file or one huge computer file or some kind of huge model file for the whole of the nation. It's not quite that. It's not one huge DWG drawing of the whole of the nation's constructed infrastructure. It's not quite that, but it is a common language of a federated set of building models around the country which can exchange information. So this is the idea of a national digital twin. And there are some very important documents that came out recently which talk about this. And the first one is the Gemini Principles, which was published by the Center for Digital Built Britain. And the Gemini Principles are kind of the conscience or the ethical drive. Why is it that we need to do a digital twin? How will this help our society? How will this help mankind? And we'll watch about a video about this in a minute. The second interesting document which came out is a pathway towards an information management framework, towards a pathway towards an information management framework for a national digital twin. And the big comparison here is with the World Wide Web. web. And the web was quite an innovation in terms of how computers can exchange information through web browsers and make content shareable and viewable by computers across the world. And a lot of thought was given to just the right amount of information standardization. You didn't want too much standardization or too little standardization. You wanted just the right amount of standardization to enable this movement of the World Wide Web to flourish. And the same thinking is now being given to an information management framework for a national digital twin, that it needs some standardization, not too little standardization that nobody can understand any other digital twin of anyone else, but not too much standardization that that nobody bothers to use adopt this standard, this information standard for a national digital twin. So we will watch a video in a second about the Gemini principles, but I just want to give you one last example to help you to understand what a national digital twin is all about. And I want you, for example, to imagine autonomous vehicles or driverless cars. So people say that this is now on the horizon. It's going to happen quite soon. For autonomous vehicles to happen, I think a car needs to be able to read data from roads and from traffic lights, and it needs to be able to perhaps even transmit data to other cars and to the infrastructure. So for something like this to happen, there needs to be some kind of information management standard where all of the roads, the bridges, the tunnels in the country have some kind of information standard, or can send and receive information about their current state to enable autonomous vehicles to use that infrastructure. And these are the kinds of applications why we are thinking about a national digital twin in the UK. So with that, I'd like to watch a video about the Gemini Principles, which are kind of the ethical or the moral drivers for a national digital twin.
The UK is developing a national digital twin, an ecosystem of connected digital twins, securely sharing infrastructure information to support better outcomes for us all. The Centre for Digital Build Britain has developed the Gemini Principles as the conscience of the national digital twin, 9 guiding values to ensure that these digital twins have purpose, maintain trust, and function effectively. The Gemini Principles are public good, meaning that digital twins must be used to deliver genuine public benefit. Value creation, so that digital twins enable improved infrastructure performance and better outcomes for people. Insight, to enable better decision-making based on better analysis of better data across the built environment. Digital twins must enable security and be secure themselves, and they should be as open as possible. The appropriate balance between security and openness is key. Digital twins must be built on data that is of sufficient quality for the purpose to which they are put. Federation, meaning that digital twins should enable connection of data from different sources and be connectable themselves. Duration, so that the data and the digital twins are properly cared for, having clear stewardship, governance, and regulation. And as technology and societies evolve, digital twins must be able to cope with that ongoing evolution. CDDB is calling on leaders involved in creating and managing the built environment to build the Gemini Principles into their digital strategies, especially for their work on digital twins. The principles will enable a values-based approach to the development of digital twins and pave the way for secure, resilient data sharing, which is at the heart of the national digital twin. The digital transformation of the built environment is happening. The time to act is now. Join us. cdbb.cam.ac.uk.
So that was a little bit about these Gemini principles, which explain or give the rationale, the drivers, the incentives, or the moral or ethical incentives for a national digital twin. So all of this was by way of context of all of these exciting things happening in our industry. Just to wrap up the second half of this presentation, I would like to present to you a couple of projects on which I have worked in recent months or the recent couple of years, which have happened in this context of the digital transformation. The first project is the 3DIR project, or the three-dimensional information retrieval project, which is essentially a BIM search engine. Nowadays, with building information models, we are cramming more and more information into our building models. Our building models are loaded with information, not just geometrical information, but lots of non-geometrical information. We are attaching documents. Our objects have lots of properties, sometimes contracts, information about suppliers, manufacturers, links to external information, web links, URLs. All of this is increasingly kind of crammed into our building information models. So our building information models, for example, something like a Revit file, a .rvt file, these files are becoming bigger and bigger and are more loaded with information. So we thought for this project that we need a search engine to help find information, very analogous to what Google does on the internet. It's essentially a search engine, but unlike the internet, information which is in a building information model has this great advantage of being linked to 3D information, to 3D geometrical information. So our thinking for the 3DIR project is how we can use this 3D information when we are assessing what is relevant, when we are giving the user a language for writing queries, for expressing what is their information need, and even when we are searching, when we are visualizing search results. So for all of this, we can use a 3D model for expressing queries, for identifying what's relevant, and for visualizing search results. We can use this 3D model to help us to do all of these things. And this is some of the thinking behind the 3DIR project. So with that, I'll play this video, which is about the 3DIR project.
3DIR is a free app for Autodesk Revit building information modeling that delivers powerful and intuitive search results for architects and civil engineers. It exploits relationships between objects in 3D models when searching for detailed information. It allows you to search for texts as attributes of 3D building objects themselves, as well as web pages or text documents linked to those objects. This enables you to search Revit models in ways simply not possible using standard Revit functionality. You can easily search for keywords within parameters and linked documents. Search results can be highlighted within the building model by being selected or isolated, or finally by being highlighted with colored markers.
So that was an example of this BIM search engine as part of the 3DIR project, where we are, unlike, for example, a web search engine, we are exploiting the 3D geometry or the link to 3D data when expressing queries, when trying to identify what's relevant and trying to measure relevance, and also when displaying search results for our search engine. As part of this, we tried to assess how well 3DIR does as a search engine. And this graph here I showed you is something called a precision recall curve. And precision is a measure of how many of your search results are actually relevant, and recall is a measure of how many of the relevant information you manage to retrieve and put in your search results. So both of those numbers are between 0 and 1, and ideally we want them both to be 1 all the time. In other words, we want this number to be, so we want this graph to be a flat line at the top near the 1 level. So the blue line on this graph, which is not very clearly visible, but you can see it towards the right-hand side of the graph. That blue line tells us that we are getting pretty decent retrieval results using 3DIR, using the Revit add-in or the Revit search engine, which is the main tool that 3DIR is. We also experimented with some information standards. We experimented with IFC, which is the yellow line, and we saw that with IFC, you have some very minor deterioration of retrieval performance with 3DIR, but probably not significant. So IFC performed very, very well. So that's like saying, in my web search engine, I will only search using I'll only search for PDF documents, rather, or only search using the text standard rather than using any other standard. So we're limiting our search to a particular information standard or a particular language, rather than using the full range of everything that we can search. And with IFC, we had some deterioration of retrieval performance, but not a lot. The third standard we looked at was this standard called Uniclass, which is extremely common in the UK. It's a classification system where every part of a building model or building information can be classified according to some kind of, almost like a library classification, like the Dewey Decimal System, almost like that. And when we limit our searching functionality to just the information we can get through Uniclass, you can see the red line on this graph that there's a lot of decay, a lot of deterioration in retrieval performance. So this is just something which is of great interest, and this is an ongoing research process for us to see how we can adopt or even improve some of these information standards without sacrificing our retrieval performance for our search engine. The next project I'd like to present to you it was a small project. It was a network funded by the Center for Digital Built Britain in the UK, the group that has, for example, established those Gemini Principles, and they gave us a grant a couple of years ago to run this network for information management. And part of their remit, or the job they gave us, was to identify the capabilities that the country needed in information management. So what did we as a country need to be good at, or we as a national construction sector in the UK need to be good at in order to deliver a digital built Britain? We identified some capabilities, which is, number one, we need to be able to gauge our information management maturity. We need to be able to establish the appropriate scope of standardization, which has come. This idea has emerged already in this presentation. The right amount of standardization, not too much that nobody adopts the standard, but not too little that nobody can talk to anybody else using a common language. We need to be able to design or extend existing ontologies in general, but in particular, we need to be able to develop current classification systems, Uniclass in particular. So Uniclass emerged as something that was quite important in the UK, and we need to be able to work with that standard in particular. We need to be able to develop information management software, and the report, the final report, and I've given you a link there on the left-hand side. The final report talks a little bit more precisely about some of the software functionality which is needed. And the final capability is to able to identify or to derive business value from information management. And that's similar to what Project 13 said, which is that we need business models which help us which act as incentives for us to work in the way that we need to work to deliver a digital Built Britain. The final project I'd like to present to you, just to wrap up this presentation now, is a project which was led by my colleague, Dr. Manuel de Villa from University of the West of England. And this was a project looking at virtual reality and augmented reality in the construction sector. And over 1 year, we had several very important meetings and workshops with stakeholders from around the industry, both builders, designers, clients or building owners, as well as technology and software vendors. And we met several times over a year to try to set out a research agenda for adopting or exploiting virtual reality and augmented reality in the construction sector. And as part of that, we set out this agenda here that you can see on the image. The vertical axis divides some of the agenda items into 3 categories: so system development, technology development, and proof of concept. The horizontal axis is the time scale in terms of years. So things from immediately when we publish this paper, and this paper was just published last month, even though this research was conducted over the course of last year. So the time scales are from 1 year all the way to 12 years, and under each of the 3 categories there, we've identified some of the very important research agenda items which need to happen in our industry. So those were 3 examples of projects: the 3DIR project, the Network Fountain, this National Network on Information Management, and this project about augmented reality and virtual reality. I would like to wrap up with a few concluding thoughts about the current digital transformation in our sector. I feel, and many others do as well, that the UK is emerging as a world leader in this domain. I think the UK was one of the first nations to mandate BIM in a structured, formal way. Many people now talk about Industry 4.0, and if I was giving this presentation in a physical classroom, I would have loved to look at your faces and to see whether there's whether anyone had come across this idea of Industry 4.0. But Industry 4.0 is kind of the 4th industrial revolution, or the 4th version of an industry which we have as mankind, as a society, or as the human race. And of course, in the first industrial revolution, so Industry 1.0, I think that happened in the UK a couple of centuries ago. And I always think whether people who were alive at that time were aware of what a key period in the history of humanity they were experiencing, when people gradually started to move from the farms to the cities and started to produce things and to manufacture things in factories. When all of this wave was happening, maybe in the life of individual people it seemed quite gradual, but now that with the hindsight of history, this was a very radical and a very swift revolution that was happening in a relatively short time. And I wonder whether the people who were alive at that time were aware of what an exciting time this was for humanity. And in the same spirit, I wonder whether we, as professionals, students, academics working in the built environment, are fully aware of what an exciting time it is for us as our sector undergoes this digital transformation. We probably won't know completely until we do have the hindsight of history in a few decades or many years from now, when we can look back and really reflect and analyze on what's happening in what has happened in our industry. But I do believe that this is an exciting time to be working in the built environment. Very, very exciting time, as our whole industry is being revolutionized and being digitally transformed. So that's it for my presentation. As I am in front of such a distinguished audience this afternoon, I thought I'd just take a couple of minutes just to tell you a little bit more about our department. So I am from the School of Architecture, Building and Civil Engineering at Loughborough University, and our vision is to become the world-leading integrated center for the built environment. We're not only civil engineers, we're not only a construction team, we're not only building services and building performance and architectural engineering, we're not only architecture, we're not only transport, we're all of those things together, working together in an integrated way to deliver world-leading teaching and research and scholarship to do with the built environment. So I'm very proud to be part of that school, and I've given you a link to our school there. I am also the program director for 3 of our construction MSc programs: the MSc in Construction Management, the MSc in Construction Project Management, and the MSc in Construction Project Management with BIM. And I've also listed there a 4th program, which is the MSc in Sustainable Design and Construction. Certainly, our construction programs are the 2nd oldest in the world after Stanford University, which is where I was at before I joined Loughborough University. And we enjoy a great heritage at Loughborough University in delivering construction education at a postgraduate level. So I'd welcome anybody who has any questions to ask me any questions about this as well. So with that's all for my presentation. Thank you very much to my colleagues for inviting me to be with you this afternoon. And
thank you, Professor. Thank you for the valuable information. Our participants are having few doubts. Shall I ask one by one?
Yes, please.
Mr. Gokul Krishnan has asked, what are the problems and challenges facing in digital twin technology?
That's a very good question. I think digital twin technology is still at its infancy. I think at an individual building scale, I think it's actually quite, even though it's a new idea, it's actually now probably quite mature. We used to talk about BIM models, and we used to talk about BIMs for helping you to operate and maintain a building. So when you design a building, and maybe when you build a building, you use a BIM, you use a building information model, and the idea of BIM is that maybe you can keep this building, you can keep this model even as you operate and maintain this building. And there are things such as COBE, the information exchange for built facilities as they're being operated and maintained. So a digital twin for individual building, I think, is quite a mature idea, and we now know even how we can use BIMs, building information models, while we operate and maintain a building. So we don't just throw away or discard all of this information as soon as we buy the building, but we keep this information and we use this information as we're operating and maintaining a building. I think the bigger challenge we're now facing is about doing this on a national scale, or at least on a much wider scale than an individual building. And we will need to do this, especially if we're trying to operate and maintain linear or horizontal infrastructure, roads, railways, maybe even kind of networks of buildings rather than individual buildings. These kinds of things require us to model our buildings at a much bigger scale or a much wider scope. And I think this is where the challenge for information, for digital twins is currently at. Because to do that, we need some very careful information standards so that people can talk the same language and can communicate with each other using the same language.
Thank you, sir. And a few more questions, sir. What technology is needed to create digital twin? When to develop and use this twin strategy?
I'm sorry, can you try to repeat the question? I think the audio just broke up very briefly.
Yes, sir. What technology is needed to create digital twin, and when to develop or use a digital twin strategy?
Okay, well, I think what technology is needed to develop a digital twin? I think there are two scenarios. I think the first scenario is a building which was delivered digitally. In other words, a building which was designed and constructed in a digital way. I think if you design and construct your building in a digital way, then by the time you have the building, by the time you finish the construction of the building, you've already got a digital twin ready for you to use. So the physical twin has been developed, has been born, but the digital twin remains, and you can keep both twins in a digital twin kind of way. So this is the first scenario. I think the second scenario is a building which was not built, which was not designed and constructed in a digital way. And for that, in order to have a digital twin, you need laser scanning or photogrammetry technology. You need to be you need that family of tools in order to scan your building, to scan the physical building and generate a digital twin out of the physical building. And this is also, I think, probably quite mature, although there's still a lot of research going on in this area, because these kinds of scanning technologies give you what are essentially point clouds, and then converting these point clouds into a meaningful building model or a meaningful digital twin where you have objects with parameters. I think that's quite a difficult step to do, to convert a point cloud to building objects with parameters, i.e. a digital twin. But that's the kind of technology that you need, and even tools like Revit, for example, have add-ons where you can import point clouds and convert them into Revit objects. So that was the first question about what technology you use to have a digital twin, either a BIM model or the building is developed using a BIM model, or things like laser scanning and photogrammetry. The second question, when should we have a digital twin strategy? I think probably very early on. I think even when you are at the very beginning, when you are designing a building, I think that's when you should plan for the whole life of the building, and even for operating it and maintaining it in a smart way using a digital twin. And if you do that during the design phase, then your building will be designed and constructed using digital technology, and you will have a digital twin to help you to operate and maintain your building as you're using it.
Thank you, sir. And another question, whether the data of building information system stored in private or in government, whether it is safe?
Yeah, I think this is a big issue with with this digital transformation. And in fact, even before the current, even for the past few years, we have had this idea of information security was a huge problem. Both information security in terms of hacking and people stealing information, but also in terms of this information, if information going into the wrong hands, for example, for counter-terrorism, and the UK government, I said they wanted all of the buildings delivered using BIM, but they were equally frightened, for example, about some of the railway stations and stuff like that. If these public buildings had very detailed BIM models that fell into the hands of terrorist groups, these BIM models essentially had every single camera and every single security point. Everything is modeled inside this BIM model. So how is all of this? How can all of this information be kept secure? So this was a huge problem. And in fact, in the UK, we have a standard now which talks about this, which is PAS 1192 Part 5, I believe it's called. So I can share this link with anyone, but this is a public standard which you can download and look at, which tells you quite precisely what you need to do to keep your information secure. So I thank my colleague who asked this question. This is really an excellent question. I think this is something which the UK is still grappling with, and there are standards that tell you what to do, especially because in the BIM world, none of this information is sitting on your computer. I'm tapping here my laptop, which is sitting on my desk. None of my information is sitting on my desk inside my computer. All of this information is in the cloud. It's in servers around the world using third-party platforms that I don't know who runs them and how securely they keep their information. So a huge issue, very important issue, and it's an excellent question.
Thank you, sir. And what is the difference between the economy, between the normal building and digital sized building?
What is the difference between a normal building and a digital?
Digital twin building, yeah, this technology, strategy building.
Well, I think that there is no difference at all. I think all it is a building which has a digital twin associated with it, essentially just has a model sitting with it. So, for example, if in my own house, I live now in a house in England. If in my own house, if I had a model on my computer which was a model of my house, then I live in the physical twin, and inside my computer there is the digital twin. Now, what would make this even more valuable is if, for example, I had a smart energy meter which measures how much energy I'm using on a daily basis, how much electricity I'm using on a daily basis, and if it feeds that information into the model of my computer, then becomes a true digital twin where information is going from the physical twin to the digital twin. So it's just that kind of thinking. But other than that, there is no difference. I think I could make my house into a physical twin with a digital twin on my computer, and I could collect data from my house and automatically import it into the digital twin, which is the model of my house in my computer.
Thank you, sir. And another question, whether the BIM can be used for pavement engineering.
Pavement engineering.
Highways.
Yes.
Roadways.
Yeah. Yes. Actually, this is also a very good question. I was a part of a group a few years ago, which was about BIM for infrastructure, roads and highways and even railways, and in this group there were two subgroups of people, and the first subgroup of people used to say, actually, BIM for buildings is very easy, because it's very easy to say in a building you've got a beam and a column and a slab and a frame and some panels, and you can very easily break down a building into objects, and you can model those objects in a parametric BIM modeling kind of way. So BIM for buildings is very easy. Now, if you talk about BIM for highways, pavement engineering, highway engineering, roads, railway, even for the rail, for linear, this kind of linear horizontal infrastructure, one group used to say, actually, it's very difficult to break down these kinds of things into objects and model them in a BIM kind of way. However, another subgroup used to say, of course, you know, everything can be broken down into objects and everything can be modeled in a BIM way, and even our roads have segments and sectors and components, and we can break them down just as easily into layers and strata and different segments of road. So it's not a problem at all to model to model roads and highways using BIM technology.
Thank you, sir. And last question from Dr. Sudarshan. Can you please suggest some topics for young research scholars?
This is a very good question as well. I think anything to do with digital twins is a great research topic. I think many people approach me and want to do research about BIM, want to do PhDs about BIM, want to write their master's dissertation about BIM. And I think BIM is still a very important topic. But I always say to them, you know what, I think in 10 years' time, or in 15 years' time, or in 20 years' time, I think very few people will be talking about BIM anymore. I think people will be talking about digital twins, and not only digital twins at the small scale of a building, but at a much wider scale of cities, things like smart cities, or even at a national scale. I think those kinds of topics are very, very important. Similarly, things to do with information management, and information management is it's almost like the language that we speak, and how we know what language we need to speak. I think is quite quite an important topic.
Thank you, sir. I think we have come to the end of our session, and our participants are very eager and enthusiastically attended and gave the cooperation for this new topic, which we are not that much aware of this particular topic. We had topics which is related to CAD, those things, but this one is very new to India. And here we are not at all using this BIM technology or twin strategy technology in all the places. Only few buildings like IT sector and a few industries, MNC companies are using it. I think this particular field will be going to grab our civil engineering and occupy, and it will give us a lot of information about the building in emergency time, I think so. So our participants will be using this technology for the research purpose and for the implementation in a real-time project. I want to thank Dr. Peter Damon, who is from London, on behalf of our EASWARI Engineering College and the Department of Civil Engineering. This international webinar series 2, we want to thank all the participants and our speaker once again. Thank you for
Thank
this
you.
valuable time, sir. Thank you.
A word of thanks for me. Thank you very much for inviting me. It's been a privilege for me to be with such a distinguished audience of very clever people from EASWARI Engineering College. Thank you to my colleague Daya Chandran for inviting me, and for all the people who invited me. Thank you very much for having me today.
Thank you, sir. Thank you. Participants, thank you for the participation. And the slide is available for the feedback link. I think it is visible in the presentation thing, and you can give your feedback in the link. And tomorrow at the same time, 2:30, we will be having another session. And we are distinctively using various topics, interdisciplinary topics in civil engineering. And tomorrow also same like that, we are having a different topic. Akanshu Sharma, Dr. Akanshu Sharma from Germany, he will be presenting in performance-based seismic design and strengthening with focus on fastening. Once again, I will repeat, Dr. Akanshu Sharma from Germany, and he will be speaking on performance-based seismic design and strengthening with focus of fastening. I want all our participants to participate in all the 3 sessions so that they will be gaining a lot of knowledges in various interdisciplinaries of civil engineering. Thank you. Thank you so much. Participants, you can use the feedback link which is available in the presentation slide. You can see Jyoti Lakshmi in the name. The presentation slide is available and the feedback link is emerged in that slide. You can use it. Thank you. All the participants will be getting the e-certificate through their mail after the 3 sessions. Maybe it will take 1 or 2 days. In the end, they are getting e-certificate. Thank you.